Picture this: a strange object from the far reaches of space whizzes past Earth, and just as it begins to drift away, it suddenly speeds up. This was the case with Oumuamua, an interstellar visitor that left scientists scratching their heads. Why did it speed up? What forces could have acted on it? Today, we're diving into the possible explanations behind this strange phenomenon and what it could mean for our understanding of the universe. 7 years ago, astronomers made a groundbreaking discovery: an interstellar visitor from beyond our solar system. Nicknamed Oumuamua, this object sparked intense debate and curiosity, with one central question at its core: what exactly is it? Was it a comet, an asteroid, or something else entirely? Oumuamua presented a puzzling mystery to scientists. While it was initially thought to be similar to a comet or asteroid, its behavior didn't match up. The biggest twist? As Oumuamua passed close to the Sun, it unexpectedly sped up a burst of acceleration that defied explanation. This unusual boost led some to wonder, could it be an alien spacecraft? Even Harvard professor Avi Loeb entertained this idea, sparking worldwide intrigue and speculation. But now, astronomers believe they may have finally cracked the code: Oumuamua's strange acceleration. And the answer, as it turns out, doesn't seem to involve alien civilizations or extraterrestrial technology. On October 19, 2017, Robert Warwick made a milestone discovery, identifying Oumuamua as the first known object to enter our solar system from interstellar space. While the scientific community initially celebrated, excitement quickly shifted to confusion. The properties of Oumuamua were so unusual that scientists were left wondering, what are we really dealing with here? As new data emerges, researchers are closer than ever to understanding the true nature of this interstellar traveler. Named Oumuamua, meaning leader or scout, this mysterious object from beyond our solar system initially had astronomers convinced it was a comet. But that theory quickly fell apart. Oumuamua had no tail or coma, the telltale features that define a comet. So, only a week after its discovery, experts did a turnaround and reclassified Oumuamua as an asteroid. Case closed? Not exactly. Soon, scientists noticed something odd. While most asteroids follow predictable patterns, Oumuamua's behavior defied everything we knew. Discovered on October 19, 2017, Oumuamua was already on its way back into interstellar space. Calculations revealed it had swung by the Sun, reaching its closest approach, known as perihelion, on September 9, coming within 37.6 million kilometers. But as it began moving away, scientists noticed something mind-boggling. Oumuamua was accelerating faster than gravity alone could explain. This mysterious acceleration baffled scientists. Could it be a natural phenomenon or something else? After detecting Oumuamua's unexpected acceleration, scientists were faced with a pressing question: what was driving this mysterious speed boost? At first, they speculated it might be due to outgassing, a process where volatile gases escape from a heated body, creating a jet-like effect. This wasn't far-fetched, as it's a common occurrence in space when objects are heated by the Sun. But there was a catch. Normally, outgassing would cause a noticeable change in an object's rotation, and in Oumuamua's case, no such change was observed. This deepened the mystery. Determined to uncover Oumuamua's secrets, astronomers directed nearly every telescope available toward the interstellar visitor. Through this close observation, they discovered that the object exhibited extreme fluctuations in brightness, suggesting it was shaped like a giant, elongated cigar. However, despite the data, scientists struggled to reconcile these brightness shifts with a rotation pattern that made sense. As it stands, the true nature of Oumuamua remains elusive, leaving us with more questions than answers about this intriguing interstellar scout. Instead of rotating around one of its main axes, Oumuamua seems to lurch through space in an unpredictable manner. To make matters even more perplexing, scientists found no dust in its vicinity. This led to the intriguing hypothesis that Oumuamua might not contain any water and could be composed entirely of metal. Determining its exact dimensions has proven challenging as well. Without concrete data, scientists have had to rely on estimates based on factors like reflectivity, density, internal tensile strength, and axis of rotation. This means that Oumuamua could measure anywhere from 100 to 800 meters long. As for its origin, researchers have yet to pinpoint a clear answer. The best guess suggests that it hails from somewhere in the constellation Lyra. Shortly after being classified as an asteroid, it was reclassified as a comet, though not all scientists agree with this designation. Some studies propose that Oumuamua may actually consist of frozen hydrogen or even be a fragment of nitrogen ice blasted from a Pluto-like exoplanet. But the theories don't stop there. Harvard professor Avi Loeb has taken a more controversial stance, suggesting that Oumuamua might be something far more intriguing. As the debate continues, Oumuamua remains one of the most enigmatic objects we've ever encountered, sparking fascination and speculation across the scientific community. Avi Loeb has put forth a bold theory. What if Oumuamua isn't a natural object at all, but rather an artificially created one? This notion leads to a provocative question. Could it be an alien spacecraft? Loeb is not exactly a low-key astrophysicist. He has made headlines before, claiming to have discovered mysterious objects at the bottom of the Pacific Ocean that suggest extraterrestrial technology. These claims revolve around hundreds of tiny spheres of interstellar origin that he alleges were found among the remnants of a meteorite. You might also recall the sensational presentation of alleged alien mummies in the Mexican parliament back in September 2023. Loeb was even live-streamed from Harvard, discussing the search for extraterrestrial objects in our atmosphere and solar system. Given his track record, Loeb's comments about Oumuamua don't seem all that surprising. He speculates that this interstellar visitor could indeed be an artificial construct from an advanced extraterrestrial civilization. The peculiar acceleration and the absence of dust around Oumuamua align perfectly with the characteristics we'd expect from a thin object with a large surface area. Could it be that Oumuamua is not just a cosmic anomaly, but a glimpse into the possibility of intelligent life beyond our planet? The debate continues, leaving us with more questions than answers. One intriguing theory suggests that Oumuamua might actually be a solar sail, a spacecraft propelled by the radiation pressure of the sun or another star. But if you think the rest of the scientific community dismissed Avi Loeb's ideas as mere nonsense, you'd be mistaken. In fact, the possibility of an artificial origin was at least entertained. This curiosity led the Green Bank Observatory in West Virginia to turn its radio telescope toward Oumuamua, searching for any potential signals of artificial origin. Unfortunately, a few weeks later, alien enthusiasts received some sobering news. No evidence of artificial signals was detected. As technical drives became less likely as a cause for the object's acceleration, experts began to seek more natural explanations. Although Oumuamua was discovered in October 2017, it wasn't until March 2023 that astronomers finally revealed some encouraging news. They believed they had cracked the mystery surrounding our interstellar visitor. While the explanation offered does not involve solar sails or extraterrestrial civilizations, the door remains slightly ajar for the more alternative theories. For those still holding out hope for a cosmic connection, the search for answers continues. While many ideas remain purely theoretical and haven't been directly proven, they offer plausible solutions to the enigma of Oumuamua. One thing is clear: no researcher has ever observed a comet without a dust coma that accelerates in such a peculiar manner as Oumuamua. However, Daryl Seligman and Jennifer Bergner have managed to weave together these strange circumstances into a coherent theory. According to these experts, the key to understanding Oumuamua lies in hydrogen propulsion. Their conclusion emerged from examining a series of laboratory experiments conducted from the 1970S to the 1990C. These tests revealed that water ice can break down into molecular hydrogen when exposed to intense cosmic radiation. As an object moves through the interstellar medium, it effectively gets cooked by this radiation. Given this context, it seems reasonable to speculate that Oumuamua could have generated hydrogen. Yet, there's a catch. For this hydrogen to explain the object's acceleration after its orbit around the Sun, it shouldn't have escaped into space immediately. Fortunately, Seligman and Bergner have continued to explore this theory, seeking solutions to the conundrum. The journey to fully understand Oumuamua is ongoing, but the prospect of hydrogen propulsion adds an exciting layer to this interstellar mystery. Jennifer Bergner had a compelling solution for the hydrogen puzzle as well. She proposed that the hydrogen initially remained trapped within the ice's pores. Theoretical calculations suggest this isn't far-fetched. Most hydrogen formed in ice under interstellar conditions stays confined within the water matrix. This changes only when the ice warms to temperatures between 258 and 133 C. Below this limit, the water ice remains amorphous, only crystallizing when it reaches the right temperature. According to the theory, as Oumuamua entered our solar system, the sun's rays heated its outer crust, triggering a transformation in the water ice. This warming opened up the pores in the ice, allowing the highly volatile hydrogen gas to escape. This is why the outgassing went unnoticed by terrestrial scientists. Molecular hydrogen simply couldn't be detected through spectroscopic investigations. Visually, Oumuamua appeared to lack the characteristic tail or coma typical of comets, leading to the impression that it wasn't outgassing at all. In contrast to conventional comet behavior, the escape of hydrogen from Oumuamua presents a fascinating twist in our understanding of this interstellar traveler. Understanding Oumuamua's acceleration, the role of hydrogen. Hydrogen wouldn't create any significant dust formation, and even if the ice matrix contained dust, it likely wouldn't have been carried away by the outgassing. But here's the crucial question. Can this unique form of outgassing explain Oumuamua's surprising speed boost? The answer is yes, if we assume the object is relatively compact. In the case of a large comet, several kilometers in size, outgassing wouldn't have much impact on its flight behavior. However, if Oumuamua is only about 100 meters long and 20 meters thick, the hydrogen outgassing could generate enough thrust to account for the observed acceleration. First, let's understand what Oumuamua actually is. Discovered in October 2017, this object was the first ever recorded interstellar visitor in our solar system. Oumuamua's shape was unlike anything we'd seen before long, and cigar-shaped, about 800 meters long, but only about 80 meters wide. Scientists initially thought it was a comet or asteroid, but it lacked some key characteristics, like a tail. This raised an important question. What exactly was Oumuamua? Its unusual shape and lack of a visible trail made scientists wonder if it might be something entirely new, or, as some speculated, even an alien probe. Oumuamua's journey through our solar system was quick, and scientists didn't have much time to observe it. But here's the thing that really puzzled astronomers. As Oumuamua began moving away from the sun, it accelerated. Now, if it had been a regular asteroid, its speed would gradually decrease. So what could explain this sudden boost? The usual suspects, like gravity from nearby planets or solar radiation, weren't sufficient. What's more, Oumuamua didn't have the usual tail of gas and dust, which we would expect from a comet accelerating under the sun's influence. This unexpected behavior left scientists grasping at straws for possible explanations. One of the most prominent theories to explain Oumuamua's acceleration is solar radiation pressure. Here's how it works. The sun emits photons, and when these photons hit an object, they can transfer momentum to it. For a lightweight, thin object, this pressure can cause acceleration. Scientists speculate that if Oumuamua was unusually thin, possibly just a few millimeters thick, then it might have acted like a solar sail, absorbing enough radiation from the sun to speed up. But here's the thing. Oumuamua would have to be incredibly lightweight and thin for this to work. Could nature create such an object? Or might there be another explanation entirely? Another intriguing theory is the hydrogen icebergs hypothesis. According to this idea, Oumuamua could be made of solid hydrogen. This is highly unusual, since hydrogen doesn't typically form into solid structures. But if it were a block of frozen hydrogen, sunlight could cause it to sublimate, meaning it would turn directly from a solid into a gas, generating a force that would propel it forward. Since hydrogen is invisible in most wavelengths, this outgassing wouldn't create a visible tail, which could explain why we didn't see one. Although it's an interesting idea, forming a solid hydrogen object in interstellar space would require extremely specific conditions, making this hypothesis a bit of a stretch. Perhaps the most captivating theory, and the one that has captured the public's imagination, is that Oumuamua could be an alien probe. Harvard astronomer Avi Loeb famously proposed this idea, suggesting that the object's odd acceleration and lack of typical characteristics could indicate it's an artificial object sent by an advanced civilization. He even speculated it might be a light sail, a form of spacecraft that uses radiation for propulsion. While most scientists are skeptical and favor natural explanations, this theory remains popular in discussions, sparking debates about the possibility of extraterrestrial life and the nature of interstellar objects. To fully grasp the phenomenon of Oumuamua's acceleration, let's take a closer look at its path. After being detected on October 19, 2017, Oumuamua passed within 24 million miles of Earth on its journey through our solar system. Initially, it came from the direction of the constellation Lyra, indicating it had traveled a long distance before reaching us. Its hyperbolic trajectory suggested it was not bound to the Sun, meaning it was on a one-way trip through our solar system. This unusual path is what set it apart from other celestial bodies and drew intense interest from astronomers worldwide. One of the methods scientists used to study Oumuamua was analyzing its light curves. As it passed by, astronomers noticed fluctuations in brightness, which indicated that the object was rotating. By measuring these light curves, researchers estimated that Oumuamua completed a full rotation every 7.3 hours. These measurements provided insights into its shape and surface characteristics, but they also highlighted the challenges of studying such a fast-moving object. The rapid rotation and varying brightness made it difficult to determine its composition and physical properties, adding another layer to the mystery. Oumuamua was not just another asteroid. It was moving incredibly fast, about 196,000 miles per hour. This immense speed had implications for how we detected and studied it. As it sped through our solar system, it had a limited window for observation, making it challenging for astronomers to gather data. Furthermore, its speed means it originated from outside our solar system, providing a unique opportunity to study interstellar objects. However, its quick passage also raised questions about how many more Oumuamua-like objects are out there, lurking beyond our current observational capabilities. The scientific community faced several challenges in studying Oumuamua. For starters, the technology we have is primarily designed for detecting objects within our solar system. As a result, catching an interstellar object like Oumuamua was somewhat of a stroke of luck. The limitations of current telescopes, combined with the object's high speed, meant that researchers had to rely on rapid observations and data analysis to piece together its character and do not exhibit this behavior. Oumuamua's lack of a tail led to speculation about its composition. It didn't fit neatly into either category, which is part of what made its discovery so intriguing. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blesovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.